if I say make 8-bit adder, using two actually 4-bit adder. To change this to two 4-bit adder. So that means what we right now for making, first you need to understand what's the meaning of the 8-bit adder, right? You tell me. If I just consider as a unit for the 8-bit adder, right? So if I consider as a 8-bit adder, if I say, okay, I have one unit like this, I call that a bit adder. So you tell me how many inputs we should have for 8-bit adder. Type it on the chat box. How many inputs we have? 17, definitely, right? Whenever you say 8-bit adders, so it should be I have actually one X, but this time X actually should has 7 bits. That means it should be start with the X0 and end up with X7, right? 8 bits. So then you should have the Y, okay? So Y definitely should has 8 bits, start with Y0 and end up with Y7, right? So definitely similar with the 4-bit adder, you could have one C in, right? So now tell me about the output. Whenever you add two 8-bit, which is this is 1 and this is the second one. So how many outputs we should have for 8-bit adders? Type it on the chat box. So you are adding the two numbers with 8 bits. How many bits you could have? How many bits? Just guess. So yeah, 9. Definitely. Whenever you add two numbers with the 8 bits, the only possibility is you could get 8 bits again. The other possibility is you just produce the carry, right? The carry, you just add one more bits, right? So that means definitely you should have 9 of them. So that means you have, if I call S, so you will have S0 to S7, which is the 8-bit. We call this actually the S. And if you get the carry, you tell me which label is good to put here. What should be the number of the C? Should be C based on what we had in the 4-bit adder. What should be this label? No, so see, whenever you put, yeah, it should be 8, definitely, right? So whenever you say 8, so you exactly show the what is the carry. You start with the 0, 1, 2, 3, 7. Whenever you have the carry, that carry should be actually 8, right? Whenever that's 4-bit, you start 0 to 3. If it's make the carry, it should be 4, right? So here is the same thing. You have 0 to 7. What's carry means it's actually should be C8. So that means this is 2 power 0. This is actually should be 2 power 7, right? This is 2 power 6 because you start with the 0. So that's a good label for this is C8, okay? If you want to actually make that more easiest for you, so let's do this. Maybe that's actually more clear what I'm talking here.
So that means this is what you want to, whenever you design anything, first you should understand exactly what you want, what you are going to do. So the x is this, x7 is x6 is x5 is x4. So then is x3, x2, x1, and x0. Same thing, you have y0, y1, y2, y3, y4, and y5, y6, and y7. If you want to have the carry, cin, definitely you add here, you say add, and you got this, okay? So you got actually the S0, S1, S2, S3, S4, S5, S6, and S7. And see where is the C8? Definitely is a carry. So that means whenever you add these two, and if you have get the carry from this, you add these three. So that means this is possible you get the carry, right? So if that's a carry, it goes to the C8. If not, the C8 will be 0, right? So what tools we have here? Just again, check what we want to do. We want to make 8-bit adder. We understand how the 8-bit adder should be. But the only tools you have just 2-bit, you have just two 4-bit adders, okay? You could do this exactly in the lab because in the lab we have two 4-bit adders. So that means with that one IC package, you could actually make whatever we are going to make today. So let's just go a little up. Okay. So let's use some other color here, probably use this. Okay. So what I just have a two 4-bit adder. Okay. So I actually just draw that whatever I have. So this is the first one. This is 4-bit adder. This is a second one. Again, this is 4-bit adder. So definitely you have actually 4 inputs, 1, 2, 3, 4. You have another 1, 2, 3, 4, and you have one C in, right? So the same thing for this. You have 1, 2, 3, 4. You have 1, 2, 3, 4. You have one carry in, which is here. So then you also have 4 outputs, right? So I actually draw them later, okay? So first, I want to use these two and able to design this. So let's just take a look to this. Whenever you want to add these two numbers, so I just have 4-bit adder. I'm able to add two numbers with 4 bits. Could I actually consider these first? Could I say, okay, let's first add x0 to x3 with y0 and y3 with the same. So whatever, could I add these two numbers? The answer is yes, because in the reality, you do the same thing, right? You just add this, whatever you got here as a carry, you actually use that carry that you have for the second half, which is second half again is adding 4 two numbers with the 4 bits. So that means I could use the next one. So what should be this carry? This carry is the carry that you have for first actually add. You should be the carry in for the second one. So at least I know this should be connected to here, right? So why? Because whenever you add this with this, whatever you get as a C4, it actually comes here, which is you consider as a C in for the second
4-bit adder. So based off that, you tell me which inputs I need to put here. Tell it's their label. What should be this for? Type it on the chat box. What we should have here, for example, what you are going to do, you want to add x0, x1, x2, x3 with the next one. So that means I just connect x0 here. Yeah, definitely. x1 here, x2 here, x3 here. First, you need to add with y0. So the next should be y0, y1, y2, y3 plus c in, which is no problem, okay? So if you call this c4, so c, this is the c4. So that means whenever you add these three, you got the carry. But in the reality, if this is 8-bit, its carry should becomes here. So that means should be c in for the next 4-bit adder. That's the reason I actually connect this C4 to Cin of the 4-bit next second 4-bit adder, okay? What should be the inputs here? These 4 should be what? Start with which number? Yeah, definitely should be the second one, which is the X4, X5, X6, X7, and the same thing here, Y7, sorry, Y4, y5, y6, and y7. Okay, so just forget here about the output. Whenever you add these first 4 with these first 4, should be the output. The first output should be S0, right? The next output is S1, right? The next output is S2. The next output is S3, okay? Same thing here. Whenever you add x4 plus y4, it is S4, right? So that means the first one should be S4, the next one should be S5, the next one should be S6, and the next should be S7. And whatever you have as a carry out for the second one, definitely that is C8, right? So whatever you have here is your C8, okay? So that's it. So see, you actually made one 8-bit adder with just using the 4-bit adder. So what